Breaking the sterile myth. To understand why the drill stopped, we need to go back to the first clean controls that refused to be quiet. A hematology team ran routine sequencing on marrow aspirates from healthy donors. Bacterial DNA showed up where textbooks promised nothing. First instinct, contamination. They rebuilt the protocol from the floor up. Double skin preps, sealed needles, single-use drills, air plates open beside the field, and reagent blanks riding every step. The signal shrank, but it didn't die. Proteobacteria, Actinobacteria. Not a bloom, just a whisper that wouldn't leave.
Stakes land fast. If sterile bone is a myth, you don't just worry about infections. You rethink remodeling. Osteoblasts and osteoclasts do their work inches from immune cells listening for microbial cues. If quiet residents sit in microchannels, then antibiotics, implants, even diet could be nudging density without anyone seeing the hand on the lever. Overtreat noise and you might silence the guidance system that keeps bone steady. Proof in low biomass biology is unforgiving. Teams layered methods, 16 srRNA amplicon sequencing to flag who might be there. Shotgun metagenomics to sharpen the picture and subtract known contaminants. Orthogonal detection to get beyond DNA fragments. In a subset of carefully handled bone shavings and marrow-adjacent cores, fluorescence in situ hybridization with ribosomal probes lit up tiny punctate-tracing, canal-like paths. Live, dead dyes suggested membranes intact in a few clusters. Confocal stacks mapped dots lining the lacuno-canalicular network, the same tunnels where osteocytes sent strain and passed messages. Meanwhile, skeptics aimed where they should. Skin flora sneaks in, drills aerosolize, post-mortem bones get colonized, reagent kits are dirty. So labs escalated. Samples moved into sterile isolators. Ultra-pure ancient DNA kits replaced standard reagents. Negative controls outnumbered samples. Some signals vanished under that pressure, which mattered. The ones that stayed began to look real. Across sites, the same lean phyla popped up in bone more than in blanks, and spatial mapping showed pockets, denser near marrow sinusoids and osteocyte neighborhoods than at the outer cortex. A micro-story captured the moment the myth cracked in practice. During an elective hip replacement, a surgeon handed off a cortical slice to a research tech who ran a rapid fluorogenic assay for bacterial enzymes as a curiosity check. It popped. They re-prepped, switched instruments, sampled a second site, and ran matched blanks. Pop again. Controls were dark, no fevers, no lytic lesions, no clinical infection, just a signal sitting where no one expected a voice. But DNA isn't life. Culture was the next hill, and it mostly failed. That wasn't surprising. If tenants exist, they're likely slow growers, adapted to mineral and low oxygen. So teams asked a different question. Activity. RNA-scope probes targeting bacterial rRNA signaled in a handful of marrow-adjacent canals when tissues were snapped into RNase inhibitors within seconds. Nanosims and Raman microscopy found tiny chemical halos, subtle mineral-to-matrix shifts and lactate signatures that fit low-level metabolism. Not decay, not disease, just life doing the bare minimum in a hard place. Parallel animal work tightened the frame. Germ-free mice, no microbes anywhere, carried skewed immune profiles and abnormal bone features that normalized when colonized with communities that ferment fiber. Add butyrate and propionate to the mix, and you watch T cells cool, osteoclastogenesis ease, and osteoblast markers climb. Even if bone's locals were sparse, the body's microbial orchestra clearly reached the skeleton. That gave the human whispers a plausible microphone. Immune cells in marrow translating microbial products into the Rankel and OPG ratio that decides build versus dissolve. Clinicians needed a line they could use on Monday morning. Was every faint read a hidden infection? No. Osteomyelitis still announces itself with pain, swelling, systemic signs, lab jumps, and imaging that can't hide lytic bites or sequestra. The low biomass signals in quiet bone were different, stable, sparse, and often sitting near osteocyte intercoms without clinical heat. The emerging position in careful circles. We're not looking at a city, we're mapping a hamlet. Residents and some people, some of the time, living near the wires. Contamination remained the dragon. One dirty kit can invent an ecosystem. That's why the field now demands dossiers.
negative controls processed alongside samples, multiple primer sets, orthogonal imaging, and when possible, RNA stabilization. Studies without that scaffolding don't move the needle. Studies with it have started to align. The same lean phyla, the same spatial bias, the same pattern of persistence across months in repeated biopsies from the same niche. The impact was immediate in thinking, slower in policy. Orthopedic teams didn't stop sterilizing instruments or shorten prophylaxis for contaminated trauma, but they did start asking whether every extended antibiotic course after clean procedures made sense if the goal was to protect healing cues. Implant researchers leaned into surfaces that coax macrophages toward pro-repair phenotypes without handing pathogens a foothold. Immunologists showed up at orthopedic conferences to talk rankle, OPG, and T-cell subsets like they were hardware specs. Meanwhile, another question sharpened. Are these locals doing work, or are they just tolerated? The best clues came from edges of fractures and elective biopsies. Where imaging flagged activity and probes glowed in canals, early callus sometimes formed cleaner, and turnover markers leaned toward formation. Correlation isn't causation, and no one called it proof, but the pattern was enough to justify the next acts. Sit at the marrow board, follow the gut wire, and test whether tuning microbial tone can safely nudge the ratio that runs the skeleton. This was the conceptual flip. Bone wasn't an inert being you protect from the world. It was an immune-literate tissue that expects quiet microbial coaching. Once you see the scaffold as a habitat, with intercoms, tenants, and hall monitors, you can't unsee it. And that sends us to the switchboard, where the voices get translated into structure. The switchboard. Immune crosstalk controls bone. Follow the whisper to the room where decisions get made. A few millimeters from osteoblasts and osteoclast precursors, T cells, B cells, and macrophages run a 2-dial panel, Rankin L and OPG. Rankin says mature the demolishers. OPG soaks up Rankin and tells them to wait. Tilt that ratio, and you tilt the month's construction report. More resorption or more formation. It isn't abstract biochemistry, it's payroll. Microbes don't phone the board directly, they send molecules. Short-chain fatty acids from gut fermentation, especially butyrate and propionate, slip into blood, cross into marrow, and change who's sitting at the console. Bits of cell wall and DNA fragments do it too, through pattern recognition hardware on immune cells and even on bone lineage cells. Toll-like receptors, nod receptors. Low, rhythmic inputs tend to coach calm. Chaotic surges light the resorption lamp. Watch a clean sequence play out. Feed fermenters with fiber, raise circulating butyrate, and T-cells skew regulatory. Those TREGs and their cytokines, IL-10, TGF-beta, quiet the room and indirectly lift OPG. B cells in that climate do more OPG, less trouble. Osteoclast precursors feel less rankle and stall. Mesenchymal stem cells find it easier to choose osteoblast over fat. Meanwhile, macrophages drift toward pro-repair phenotypes that set the stage for vessels and builders. Same marrow, different tone, different build. Now pull the opposite lever. Flatten the microbiome with a broad-spectrum antibiotic at the wrong moment, or let diet starve fermenters. Butyrate drops, barrier integrity slips, endotoxin traffic rises, and innate sensors get tapped too often. Day 17 cells expand, TNF-alpha climbs, rankle flows, osteoclastogenesis gets the green light, and osteoblast precursors lose confidence. You won't feel it that day, but 6 weeks later a stress reaction nags, a DEXA scan drifts, or a callus looks tired. Here's a micro story wired to the board. A collegiate rower stacks a high-impact block after a winter of low fiber and a recent antibiotic for strep. She feels fit. Her marrow does not. Fewer TREGs, more Th17, more Ranka-ul. 2 months in, the navicular aches, films show a slow callus. Nothing exotic happened. The switchboard took a nudge and carried it into structure. Receptors explain the sensitivity. Osteoblasts and osteoclast precursors carry toll-like receptors and nods, so even tiny local motifs can recalibrate them. A safe background of microbial fragments keeps surveillance tuned without spiking Ranka-ul. Flood it, and you get a different marrow, one that prioritizes defense and pays with bone. Hormones don't rewrite the board, they bias it. Estrogen normally reigns in rankle and supports OPG, When estrogen falls, the same microbial inputs land on a hotter audience. More Th17, more TNF-alpha, more osteoclasts. That's why overreactomized mice lose bone unless you support fermentation. Add Lactobacillus reuteri in those models and resorption eases. Add fiber that boosts butyrate and formation markers rise while osteoclastogenesis drops. The microbe isn't building bone, it's changing how the board hears the baton.
Parathyroid hormone therapy makes the point from another angle. Intermittent pulses can be anabolic if the audience is ready. In animal work, butyrate is part of that readiness. Low butyrate, blunted response. Restore it, and osteoprogenitors answer the call. Same drug, same dose, different board tone, different skeletal outcome. There's a Goldilocks problem laced through all this. Too little microbial input and you lose coaching. Immune cells drift, rankle creeps, angiogenesis underperforms. Too much, and innate sensors scream, osteoclast surge, builders stall. Precision isn't optional. It's the difference between a tuned signal and static. Zoom in on traffic. Chemokines like CCL20 respond to microbial and hormonal contexts, recruiting different T-cell subsets to perivascular seats, inches from osteoprogenitors. Those arrivals don't show up empty-handed. Some carry rankle, some carry calm. Angiogenic cues ride the same tide. Vessels that feed formation sprout better in a regulated room. The punchline is hiding in plain sight. That open loop we planted, the lever that flips build to dissolve, isn't a mystical molecule. It's the rankle to OPG balance, written each day by immune cells that have been trained by microbial products. You don't have to guess if it matters, you can watch it. Raise butyrate, see TREGs and IL-10, see OPG rise. Watch osteoclast cultures choke off in dishes and formation markers step up in marrow. Jam the innate receptors, watch rankles spike and then bone markers tilt toward loss. But you can't crash the board with blunt moves and expect grace. Carpet bomb microbes and fracture healing slows. Smother early sterile inflammation with long NSAID IG runs, and you blunt the phase that recruits architects. The right question shifts from more or less microbes to which signals, when, and for whom. Meanwhile, the room hears a choir down the hall. Even if locals whisper in bones microchannels, the gut is loud. Germ-free animals prove the point. Colonize them with fermenters, restore short-chain fatty acids, and the board cools. That's our handoff. If the switchboard sits in marrow, the remote control lives in your colon. Now we trace the wire. The gut-bone axis, remote control. Follow the wire to the colon. Every gram of fiber that escapes your small intestine lands in a fermentation tank staffed by microbes that turn leftovers into instructions. Their clearest message is short-chain fatty acids. Butyrate, propionate, acetate. Small molecules with long reach. They slip into blood, ride to marrow, and set the board's mood before any osteoclast or osteoblast gets called to the floor. Here's where it stops being theory. Raise fermentable fiber, and you raise butyrate producers. In animals, that turns down Th17 heat, lifts TREGs, and dials up OPG. Osteoclastogenesis slows. Mesenchymal stem cells pick osteoblast over fat more often. Trabeculae don't just look prettier on micro-CT, they carry load better. In overreactomized mice, the lab stand-in for estrogen loss, introducing Lactobacillus reuteri protects bone because it cools the switchboard, not because the bugs move into the femur and pour concrete. The remote control doesn't touch the beam, it talks to the foreman. Humans feel the same physics, just through thicker noise. Diets rich in legumes, whole grains, alliums, and resistant starch tend to raise circulating short-chain fatty acids and lower inflammatory tone, and bone turnover panels lean toward formation. Starve fermenters with ultra-refined menus and fiber in the single digits, and the opposite shows up. The gut lining loosens, microbial bits cross more often, innate sensors ping, and rankle gets airtime it didn't earn. You won't see it at breakfast. You'll see it months later when density lags behind your training. Antibiotics bring a complication with a calendar. When you have a real infection, you take them. But the same drug that clears a lung can flatten fermenters that keep marrow calm, give broad-spectrum agents during growth windows, and peak bone mass stalls in models. Stack courses in older adults, and fracture signals climb in population data. The pattern makes sense. Fewer butyrate producers, more inflammatory drift, a board that leans resorptive. Steer with stewardship, confirm need, narrow spectrum, stop on time, and pair courses with fibers and fermented foods before, during, and after, so the choir has a way back. There's a clinical twist that changed how endocrinologists and microbiologists talk to each other. Intermittent parathyroid hormone can be powerfully anabolic, but in animal work, its success depends on butyrate. With butyrate low, the drug taps a board that won't respond. Restore it, and osteoprogenitors answer. Same dose, different diet, different skeleton. That's not a probiotic pitch, it's a systems reminder. Therapies ride context. A micro story carries the point. A postmenopausal marathoner adds plyometrics and cleans up calcium and vitamin D. Her DEXA budges, then plateaus. Her meals still run low fiber, low ferment. She adds 30 grams of mixed fibers, consistent fermented foods, and sleeps an extra 45 minutes most nights. 6 months later, butyrate producers rise on a stool profile, CRP dips, and her bone turnover panel leans pro-formation. Training didn't change. The remote turned the volume up on builders. Not all microbes sing the same song. Strain identity matters. Lactobacillus reuteri in estrogen loss models cools resorption. Lactobacillus rhamnosus GG supports barrier and immune tone in ways that can steady the board, but it isn't a skeleton capsule. Blends without strain names are noise. Human trials are mixed because background diet, vitamin D, loading, and medications rewrite the stage. If fiber is low or a proton pump inhibitor is flattening diversity, a probiotic often shrugs. The mouth feeds the line too. Periodontitis keeps immune tone smoldering. Those signals don't stay in your jaw. They land in marrow, nudging rankle. Stabilized gums and systemic markers ease. One body, one board. The same is true for sleep and stress. Poor sleep ramps cytokines, stirs the board hot, and blunts formation even when diet behaves. Fixed sleep and fermentation's whisper carries farther. Spaceflight stress tests the axis. In microgravity, resorption jumps. Astronauts fight back with heavy resistance exercise and vitamin D, but crews that preserve fiber intake and microbial stability may soften the loss by keeping short chain. Fatty acids, steady in the marrow cooler. You can't install gravity in a capsule, but you can support the remote. So what do you pull, practically? Feed fermenters, beans, oats, barley, onions, garlic, leeks, apples, cool potatoes or rice, nuts, seeds, 25 to 35 grams a day. Add 1 to 2 fermented foods you'll actually eat. Keep protein steady so osteoblasts have bricks when the board says build. Use antibiotics only when needed, then rebuild the choir. If you trial a strain, make it a documented one. Give it 8 to 12 weeks and watch markers, not miracles. The handoff is clean. The marrow board runs your skeleton's month-to-month budget. The gut writes much of the script it reads. When that script hums with butyrate, builders hear their cue. When it crackles with inflammatory static, demolishers take the overtime. And if the remote can steer from a distance, we still have one more question to answer. Who's whispering from inside the beams themselves? Inside the fortress. Who's in the bone? Step into the fortress, and the first thing you notice is how hard it is to prove anyone lives here. Bone is low biomass territory. One dusty reagent kit can invent an ecosystem. So the serious teams treated bone like a crime scene. Elective femoral heads went straight into sterile isolators. Surgeons cored past cortex with single-use bits, while air plates and glove swabs shadowed every move. Reagent blanks wrote every extraction. 16S flag candidates, lean signatures from Proteobacteria and Actinobacteria. Shotgun metagenomics helped strip out common contaminants. After all that, a whisper remained in bone more than in the negatives. DNA alone could be fossils from commuters. The question became viability and location. Culture mostly failed, which fit the idea of slow, mineral-adapted tenants. So labs went optical. Fluorescence in situ hybridization with bacterial rRNA probes dotted tiny signals along canal-like paths in a subset of samples, especially near marrow-facing surfaces. Live, dead dyes suggested intact membranes in a few clusters. Confocal stacks traced puncta hugging the lacuno-canalicular network. The same microtunnels osteocytes used to sense strain and talk to builders and demolishers. Skeptics pressed at every seam. Could skin flora hitchhike? Could drills aerosolize? Were we seeing post-mortem colonization in disguise?
Protocols tightened further. Some groups used ultra-clean kits borrowed from ancient DNA work, pre-registered contamination controls, and immediate RNase inhibitors on tissue. RNA-scope for bacterial rRNA lit only when that snap-freeze step happened within seconds. Signals dropped to background if tissue warmed. That timing argues activity, not leftover mail. Spatial patterning turned the key. If traces were random traffic, you'd expect a smear. Instead, mapping showed pockets, higher near sinusoids in marrow, around osteocyte lacunae, and lower in outer cortex. In rare longitudinal cases where tiny edge biopsies were ethically repeated months apart, the same sparse taxa appeared in the same niche while controls stayed dark. Not a city, more like a hamlet tucked near the intercoms. Imaging labs added chemistry to location. Nanosims picked up subtle isotopic hints, local lactate enrichment and mineral to matrix tweaks around probe-positive microzones consistent with low oxygen metabolism. Raman spectra in those zones leaned toward altered collagen cross-linking, not gross decay. Bone wasn't rotting. It was hosting small negotiations at micron scale. Here's why those neighborhoods make sense. The lacuno-canalicular network is protected, perfused by slow fluid, and rich in mechanical chatter. Perivascular niches near sinusoids offer nutrients with gentler immune surveillance. If a microbe wanted a safe rental near the wires, those addresses are prime. Thin, disciplined biofilm-like layers measured in microns could eavesdrop on osteocyte talk and leak metabolites. Peptidoglycan fragments, lipoteichoic acid, maybe locally made short-chain fatty acids, into flows immune cells and osteoprogenitors actually feel. The stakes are human. If quiet tenants sit by the switchboard, they don't need mass to matter. A tiny, steady diffusion of motifs can keep pattern recognition receptors tuned so the board doesn't overreact to every bump. After microdamage, that tone might help macrophages pivot from clearing to coaching on schedule, keep angiogenesis crisp, and bias mesenchymal cells toward osteoblasts without flooding rankle ANT-edema. On the flip side, flattening everything with broad antibiotics or reading every whisper as infection risks muting signals that keep remodeling precise. Clinicians needed a line to draw. True osteomyelitis looks like a fire. Pain, heat, systemic signs, labs climbing, imaging with lytic bites or sequestra. The faint, controlled signals in quiet bone weren't that. Teams that sample low biomass tissues now travel with dossiers, air and glove swabs, reagent blanks, multiple primer sets, culture plus molecular tools, and an infection team trained to read whispers without panic. When faint reads emerge in asymptomatic bone, restraint replaces reflex. A micro-story keeps it grounded. A woman in her late 70s needed hardware removal after a well-healed ankle fracture. With consent, the team took a sliver from the callus edge. RNA-scope only signaled when tissue hit inhibitors immediately. The same lean Actinobacteria signature reappeared at the same niche in a planned relook months apart. Controls were clean. Her healing was smooth, films boring. It wasn't proof of help, but it pushed the question from, are they there? To, what do they do when we're not looking? Not every study finds the whisper. Geography, age, diet, medications, loading history, and protocol rigor probably shape who can live in the fortress and when. Think guild, not roster. The responsible position today: evidence supports microbial signatures in healthy bone and marrow. In some people, under strict controls, with orthogonal signs and select micro-niches consistent with low activity, function remains a testable, open question. The payoff is a mindset shift, already changing checklists. Keep pathogens out, surgical technique, air discipline, targeted prophylaxis, while avoiding collateral that flattens helpful cues in clean bone. Design implant surfaces that steer macrophages and osteoblasts toward repair and give pathogens no perch. And when a whisper shows up in a quiet patient, measure twice before you reach for the hose. Because the fortress isn't empty. It's guarded space with a few quiet squatters near the intercoms. Their voices are small, but the intercom feeds the floor. Next, we stress that system and watch how those cues play when a bone breaks and the site turns into a construction zone. Break, bleed, build, fracture healing as a microbial symphony. Snap a tibia and the fortress flips into choreography. First, a contained storm. Blood floods the gap. A clot forms and sterile inflammation lights the room. Neutrophils arrive to clear debris. Macrophages follow, sensing danger through pattern recognition receptors and deciding whether to attack or assist. That opening heat isn't a mistake. It's the cue that summons architects. Kill it too early and the rest of the cast misses their entrance. Let it rage too long and you scorch the stage you're trying to rebuild. Meanwhile, the remote control is already playing. Short-chain fatty acids drifting in from the gut, especially butyrate, reach marrow and bias macrophages toward pro-repair phenotypes. They still clean, but they also release IL-10 and TGF-beta, the quiet that lets endothelial cells sprout vessels into the hematoma. Those new capillaries are lifelines. Builders need oxygen, nutrients, and a way to carry out waste. When microbial tone runs calm, angiogenesis threads clean. When it runs hot, the lanes clog. Here's the stakes check. Delayed unions and non-unions can steal months or never resolve without a second surgery. That's time off work, lost independence, and pain that rewrites a life. If the first 48 hours set the tempo, diet in the weeks before a fall and antibiotic choices in the days after can tip a case from smooth bridging to a stubborn gap. Action unfolds in phases.